Thank you, everybody, for joining this second session of the Human Capital Workshop. This section, we talk about skills and commercial data, so it sounds really, really interesting. As usual, we have 3 presentations, and please ask the speaker to try and stick to the 20 minutes time. I will kind of wave my hands or put something in the chat if you make a noise when your time gets really close to the 20 minutes. And the first speaker is Elodie Andrieu from King's College London. And please, Elodie, you are welcome to start your presentation.
Thank you. So I'm just going to share my screen. So can you see my full screen?
Yes, I can see very clearly.
Okay. So hello everyone, thank you very much for attending the session, and thank you for giving me the opportunity to present this new work, so still ongoing. So I'm really looking forward to your comments and feedback. So this work is on the minimum wage and skills, evidence from job vacancy data, and it's joint work with Malgorzata and Kuczera, who is currently at the OECD. So the motivation of this paper, we wanted to look at labor demand, but from the firm side, which is less covered in the literature. And we were interested in the policy change in 2016 in the UK, where they increased the minimum wage. So the minimum wage was a nice framework for us because it's an expected increase in the labor costs for firms. And if you are a firm and you experience this increase in labor costs, you have different ways to compensate for this increase. So you might cut hirings, you can do some massive layoffs, you can increase your price, but you can also increase your productivity. So in this paper here, we're going to focus on the productivity channel, and especially on 2 different phenomena. So either you hire more educated workers, so therefore you would maybe expect from your worker to be more productive, either you might shift towards more technology intensive production, and therefore you'll be looking for workers with tech skills. The second motivation of this paper is also that the literature on the minimum wage has documented a lot of the effects at the aggregate level of employment, but we're going to look at the non-employment margins. So what we do exactly in this paper, we want to understand firms' demand for education and tech skills requirements, and therefore we're going to use the UK job online vacancies data to answer this specific question. Do employers use tech skills and education as a way to compensate for increases in labor cost? So in this presentation, just here to make clear, I'm going to focus more not on the framework of the difference in differences, but more on how we measure, in the interest of the audience, measure skills and education in our data, and then I'll go to the analysis and to results. So we use the framework of the minimum wage because it's an unexpected announcement, an unexpected policy from the firms, and literature has documented that. And our difference in difference strategy uses the variation within occupations across space, within space across occupations. So because the minimum wage policy, the minimum wage change policy in the UK is a national policy, we construct a degree of exposure. So this means to what extent your occupation is exposed to this change in policy. In other words, how we compute this, we use the share of ads below the minimum wage pre-policy within each occupation, each location. So if your occupation within a location has a high share, is highly exposed, this means that before the policy, this occupation within this location, has a high share of ads below this minimum wage. So I have more details, and if you have time or you have questions, we can discuss more on our strategy here. So our work contributes to many different literatures, so especially the literature using burning glass data, because it's the data here we're going to use, and all the different dimensions of the labor market. So the literature using this data has mainly focused on the US before, but now there's increasing works also looking at the UK labor market. We also contribute to the literature on the minimum wage and its impact on employment, but more specifically, we contribute to the literature on the minimum wage and its effect on other outcomes and non-employment margin especially. We also contribute to the literature looking at firms' responses to an increase in labor cost and here especially to the productivity channel. So more on the data, and I'll spend most of my time on the presentation here. So we use Burning Glass Technologies data. So we look only at the English labor market, and this is a matter of the education system because we will need education system here in our work. And we use the years only 2014 to 2019. And you might be aware that you have 2012 and 2013 is also available, but because of a matter of representativeness, we decide to cut the data to 2014. So what we have in this data, for those of you that are not aware, so you have the whole description, so the text of the online job posting, but you also have different variables that Burning Glass clean. So you have information for the occupation, the location, the wages, and many other variables, but also the set of skills that you need to perform the job. In this paper, so we use Burning Glass, and we are actually the first ones to measure the education qualification directly from the text of the job ad, which I will show you just in the next slide. And we are also the first ones to identify a tech level, but at the ad level. So we don't use any predetermined classifications of keywords or an occupation classification. So using the job description, the skills, we are able to have a tech level at the ad level. How we construct our education variable. So the goal is to retrieve all vacancies that clearly mention an education classification. So I've put an example here to help you understand. So here it's an example for ad for computer numerical control technician. So those are the workers working with machines in engineering kind of jobs. What we first do, so the different steps is, first we're going to have a direct matching of keywords. So education, English education related keywords. So for example, here the first step will identify HNC or BTech, which are circled here. Then we have different cleaning strategies because so we use the context. So we use four keywords before and after the keywords that we have identified in the first step in order to filter and to clean. So either to extract numerical values, for example, or to remove some kind of things that are using degree. So, for example, degree here would be captured by our education keyword matching, but degree, so you have a lot of ads where you have a degree of something else, and it's not related to education. So we clean for those occupations, for those ads, sorry. And then we also use the occupation dimension and the job titles of our online job vacancies to then allocate them to a specific mandatory education level. In the end, those ads will be removed in our analysis because there's no change over time. And finally, we have a final cleaning strategy. So for example, here in this ad, HNC and BTech will be classified as a level 3 and level 4. But there are some ads where we detected that the minimum education requirement and the maximum within that same ad, within the same ad is very large. So we removed them and we looked manually, and mainly these ads are mentioning different positions, but we decided to remove them from the sample. How to classify tech ads. So here the goal is going to be able to retrieve or to compute a tech level for all vacancies using the job description. So using the set of keywords that Burning Glass provide. There are many different advantages to this method and why we want to do that. Mainly, so the first one is going to be, so after looking a bit in the data, we found that a lot of new tech jobs, so for example, big data engineers, data architects, digital marketing data scientists, those were not captured by an ICT. So we had a previous an ICT occupation classification, which I will show you just after. They were not captured as a tech job. So we decided to create this measure here where you're looking at the skills of those ads, we will be able to identify them as a tech job here. It also allows us then to correct for some occupation misclassification, and I'll explain this a bit further, and also to have different tech levels within narrow occupation groups. So I'm going to try to convey, explain how we've done this method, and if it's not clear, we can maybe talk about it in the Q&A. So I'm going to try to make it simple. So we had this external ICT occupation classification that we take from Arrigan and their paper. And this is going to be techies, so occupations that are closely related to the installation, management, maintenance of support of ICT, etc. So these are the workers that we want because we believe that they are the workers that are implementing ICT within occupations. Within companies, sorry. So we have this external ICT occupation classifications, and we have the set of skills. So our first step is to identify or to have a techiness at the skill level. So how we do that, the techiness of a keyword is going to be the proportion or the number of times this skill appears in a techie occupations. Once we've done that, then we use a k-means clustering. So this is going to clusterize all our set of keywords into a techie, non-techie, and neutral set of keywords. So if I give you an example here, you're going to see on your top left part of the screen in the first panel, the neutral keywords. So all these keywords tend to be as often appearing in a techie occupation and in a non-techie occupation. On the top right, you're going to see the techie cluster. So for example, here you see all keywords that are related to tech stuff. So big data, SQL, Python. So it seems pretty intuitive. And then you have at the bottom left, you have your non-techie cluster. So these are going to be keywords that are appearing most of the time in a non-techie occupation as identified per our occupation classification, this external occupation classification. And those are going to be either very managerial or soft skills or manual, but more like cooking, cleaning, childcare, etc. So this is our first step. So really the output in this first step is to have by keyword, we have a techiness level and its cluster number. Then how do we go from the tech skills to hiring a tech worker? So we use this set of skills that you have at the top. So here's an example for 2 ads. Keep in mind that a job posting is just a subsample or a set of those skills. So we use, so we've used our first step here. So we have all the job postings, you have a different set of skills, and we merge it with its techiness and also its cluster number. Then we collapse at the ad level, and we're going to construct different metrics. So for example, the mean, the median, the min, and the max. However, at this point, it's a bit difficult to interpret those metrics because we constructed the techiness on all different samples, different sample size, etc. So we apply a logistic link function in order to get the probability that the employer is going to look for a tech worker. So in the end, what we have is going to be to what extent the firm is looking for, or what is the probability that the employer is looking for a tech worker, conditional on the keywords that is in its job postings. So here in our X, in our logistics, you can have all the different metrics that we computed in a step just before. However, our best preferred specification is when we have the mean techiness and the max techiness. And what I mean by preferred specification is we've done a lot of robustness checks and how good it is to predict our hiring, and you have all details in the paper. This is the specification that gives us the best accuracy. To give you an example, what we will have in the end. So here you have a set of 25 ads and you have the job titles. And this is, so here, for example, you would expect that senior IT support analyst or senior net developer have a very high probability of being a tech worker. So that's what you can see in this probability column. But interestingly, the field service engineers, which it's SOC occupation, so its occupation will not be classified as a techie worker if we used only this occupation classification, is still classified as a techie worker. As you can see that the probability of hiring a tech worker is 54%. So we do many robustness checks, and this is available in the paper if you need to have a look. And I'm just looking at that. So our final database is going to look like that. So we're going to have for each job posting. So one observation is going to be a job posting. We have this occupation classification, the area, the wage, the education that we have created, the education category. So we're going to, for this first analysis here, using this education variable, we're going to use only the graduates and non-graduates. We have then the tech probability, which we then classified into a high, medium, and low level of techiness. What can you expect from our variables and what we have in the data? So in this first panel here on the left, you're going to see The areas that are darker are going to be areas where you have a low share of ads below this minimum wage. And you can see that it's positively correlated with the areas where there's a low, where the share of ads with low education is also low. However, it's negatively correlated with the average tech. And this is, so these are statistics facts that then are motivating our results that I'm going to show in a couple of slides. So to double check our variables and to check that they are giving us what we would have expected. So here we plot the share of non-graduate vacancies, and you can see that there are many concentrated in low. So we can see on the left panel, there are many concentrated in low wage occupations, vacancies, and also they are also located and concentrated in low skilled occupations. We do the same for the tech level of ad, and as you could expect, the tech level is higher for higher wages vacancies, but you still have a non-zero level of techiness in the very low wage part of the distribution. And also they are more located in the higher skilled occupations. Now going to our framework. So as I said, we're going to use this minimum wage policy and the change in 2016. So the wage rose by a bit more than 7% here in April. And there's an announcement towards in 2015, but we control for that in the analysis. So as I explained in the motivation, a firm facing this increase in the labor cost have different channels to compensate for this increase. So they can do layoffs, but here we look at the productivity. So I showed you the data, but what we'll use actually, so the two variables we've created is to explore this change in productivity, and first the labor substitution. So there we're going to use our education variable. So the first one I've showed you, and then we're going to look at the labor technology substitution, and therefore we're going to use the tech skills requirements. So this tech level the ad level that we have computed. Our specification is a standard difference in difference specification, and I'm quickly going to go to the results. So we have time. So what do we see? So we actually do see a labor substitution. So here what I show you is overall occupations. So if we take column 2 and 4 as our preferred specification, so including all controls and our fixed effect, we do see that the change in the minimum wage seems to have increased the share of graduates and decreased the share of non-graduates here. However, so because the minimum wage is the change is towards the low part of the wage distribution, all the effects we are capturing are within more towards the low part of the distribution. So actually I should mention maybe we cannot bring these results to the whole skill distribution of the labor market, but really we are concentrating on this bottom part of the distribution. So now if we look at the low and middle skilled occupation, so where we can expect most effects, so where the wage policy has the biggest effects and where we can identify actually the effects, we see that for the graduates, the sign is what we would expect, but they are non-significant. However, we do see that the share of non-graduate ads is still significant, decreasing and a bit higher than overall occupation. Sorry. If we go to the labor technology substitution, so in the first column here, you're going to have so we are looking at the share of high-tech ads. So if it's increasing over time. So overall occupations, we do see that there's an increase in the share of high-tech ads, but once we split towards between the high-skilled occupations and the low middle-skilled occupations, so again, as I said, this is where we are identifying the effects in column 3 here. Actually, we do see that the share of high-tech ads is only significant and increasing in the low middle-skilled occupations. It's actually comforting our results that we have not a significant coefficient in the high-skilled occupations, because it tends to suggest that we are not just capturing an overall, like a structural change towards more high-tech ads here, because there's no effect in the high-skilled occupations. And as I said, and I'm going to repeat myself, the low middle skilled occupation is really where we can capture the effects of this change in policy. So we've applied a couple of robustness, and there's limits to this paper, but as robustness check, the first one we've done is instead of using burning glass to compute our exposure measure. We use the LFS employment data. However, due to the number of observations, we are only able to look at the one digit occupation level and also at the regional level. So we have less variation there. And then we also use a placebo break in the data, and all our estimates are non-significant. You might worry about this change in the graduate supply. So here, this paper focuses really on the demand side and what's going from the firms. Yes?
If you could wrap up quickly, because
okay, then I'll skip the limits, and it's maybe better for in the interest of my paper. If we go to the conclusions, so we document the response from firms' hiring behavior to a labor cost increase using this minimum wage change policy, and our results seems to suggest that there is a labor substitution and a labor technology substitution. So from a policy perspective, we believe that so policymakers set up these minimum wage policies in order to support those low income workers, but in the end they might be harmed by this policy change. In the long term, we believe that we are maybe converging toward this upskilling effect, so converging towards a more skilled and higher educated population. And just mentioning, our follow-up paper will be looking at inequalities and the spatial inequalities that this higher education and higher tech demand is towards what we are going. So thank you. Sorry, I rushed on the.
Thank you very much, Elodie. I don't see any question in the Q&A, but if somebody would like to ask a question, we only have a couple of minutes. You could either raise your hand or write quickly in the Q&A box. Okay. So Sanjeev, would you like to unmute yourself and ask your question?
Yeah, I can see.
Or if you can see, maybe you can just read it.
Can you hear me, Michela?
Okay, yes, now we can hear you. Thank you.
And I like the analysis and the presentation. And obviously, there's a lot of people doing all sorts of analysis here. There's a lot of data sets available. The skills and occupations link is very interesting. But what I was interested to know is that, for example, if you have or you're going to look at sort of various industry type differences. So, for example, there are several minimum wage type skills and occupations that are utilized across different industries, yet different industries, and also with that regional dimension, will pay different rates for the same skill set, some very close to the minimum wage, some much higher. I was wondering if there was going to be any sort of analysis, or have you actually had some thoughts in that area? Thanks.
Thank you. Thank you for this comment. Actually, we haven't looked at this industry level. One of the reasons was more from data limitations. So because we already look at the location, occupation level, having also the industry would reduce our sample size by cell to like a very low level. So we didn't want to go this way. But this could be actually a follow-up, and we could implement this industry level. And then maybe have less. So I haven't thought about that. So I'm just speaking on the top of my head. But instead of having this occupation level techie, we can have maybe this more industry dimension. We could actually. I haven't done it, but we could. Thank you.
Okay, we have a couple of questions from Adrian Ham, which are in the chat. Adrian, would you like to ask these questions? If you can unmute yourself.
I can see the question if not.
Yeah, maybe just.
No,
okay, Adrian is coming up. Adrian, I don't think you've unmuted yourself. No, I can't hear Adrian.
If not, I can just read it.
Okay, maybe just read these ones and then we'll see. Okay.
So how important in the K-means clustering? Could you identify the boundaries differently? So at first, we use the k-means clustering, thinking that in our metrics we would use, so I don't know if you remember the metrics, we've done the mean, the medium, so only using the techiness detail, but we also used like how frequent or what is the share of techie keywords. So that's why at first we use this k-means clustering. Also, we use this method to convert our step after that, because we use some kind of prediction. We look at the accuracy of our k-means clustering. So using, so how often this keyword is in a techie, and is it predicting, is it properly predicting a techie occupation? So you're using our ICT occupation classification as our true value. And we thought so this was a bit more than 92% our accuracy here. So if we were predicting correctly these these occupation using this clustering, then we would confidently go to the second step and do the matrix. And I'm not sure it's super clear what I'm saying here, but if you have more questions, the paper is not out yet, but we can actually, I can share it with you for all the detailed method. And then the second point was, did you do any exploration over the probability threshold away from the 0.5 default? So yes, we did. So the 0.5 method was just to do our also again prediction and accuracy computations. But then in the analysis, and I should have mentioned, we used the low techiness, low techie, probability of the low probability of looking. So we used categories actually. And here what I've showed as a high share, high tech, the high tech part, like classification, is much more above our 50% threshold. So it's around 70. And we've done actually some robustness to splitting down to the thresholds, and results are sticking. But the distribution is not yet 50 above, yes or no. It's more about these categories.
Great, thanks. Maybe you can hear me now.
Yeah, now we can.
Yes.
Okay, all right. Okay, great, thanks.
And then you have a question in the Q&A, and the speaker cannot speak. So you will, if you don't mind reading this question, that'd be great.
Yes. So question by Georgie Vassilev. So what do you think might be implications onto qualifications from such implications, perhaps by looking at more specific qualifications than graduate, non-graduate split shown? Yes, so exactly. So it's a shame, like in this analysis, I understand. So we've used this, we computed this very detailed education variable, and we've started by doing this graduate, non-graduate split. And this is definitely like a follow-up work. We want to split into also more like technical qualifications, so NVQs here in England, and having maybe even graduate plus, so having only looking at this PhD and above, like above graduate levels. So it's also like ongoing work. But yes, I understand that it's a shame when we have this very detailed education variable to use only the graduate and non-graduate splits. So this is also for a report.
Okay, thank you very much, Elodie. This was a very, very interesting presentation. Very interesting.
Thank you, and thank you for all your questions and comments.
And if there are no other questions, I can't see anything else. We can move on to the next speaker, who is, I think we've got two, Liz Gallagher and India Kerle, a new approach to building a skill taxonomy. The floor is yours.
Is that shared okay? Is it full screen?
I can't see it yet. Oh yes, it's coming up now. Now it's online.
Okay, over to you then, India.
Okay, great. So yes, my name's India. I'm a junior data scientist in the data analytics practice at Nesta, and myself along with Liz will be presenting a new approach to building a skills taxonomy. So this project was funded by ESCoE, and we will be using the acronym ESCoE moving forward, but this second acronym will be referring to the European Skills, Competencies, Qualifications, and Occupations Framework. So just a little housekeeping note. So in terms of what we'll be discussing today, we'll be talking about 5 key areas of our project. So firstly, I'll be introducing the skills taxonomy. Secondly, I'll be talking about 3 key areas of our methodology. Thirdly, we'll be discussing a number of applications of the UK skills taxonomy. And then fourthly and fifthly, we'll be talking about a few conclusionary points and some next steps to improving the methodology and analysis. So today we're introducing a new data-driven approach to building a UK skills taxonomy. And this improves our original approach in 3 key areas. So firstly, we're no longer relying on a proprietary list of skills that had been extracted from job adverts. And as a result, this means that we're able to predict or detect previously unseen skills. And because we're also not relying on a proprietary list of skills, this means that we are able to publish the entire taxonomy and code base, which makes this truly the first fully open UK data-driven skills taxonomy. Finally, the previous taxonomy that we built was developed almost 4 years ago, and this new taxonomy uses data up to 2021, which means that we're able to offer a more up-to-date view of UK skill demands. So in terms of the methodology, so firstly, we build a taxonomy based off of the sample of 5 million job adverts from 2015 to 2021. And we extract over 3.6 million sentences that we define as skill sentences. From those sentences, we identify over 6,600 unique skills. And then from those skills, we're able to put those in groups of different granularities, starting at the most granular with 250 level C skill groups. And then finally at its least granular with 11 level A skill groups. So in terms of the methodology, I'll be discussing the first step in our methodology, which was to identify skill sentences from job adverts. And the main motivation for doing so was to remove text within job adverts that were otherwise unrelated to skills. So these could include sentences that might be describing a company or sentences that are call to action, like apply here or click here. And at a pretty high level, the way that we did this was we trained a supervised machine learning model to classify sentences within job adverts as likely to be containing skills. So I guess 2 important preambles. So firstly, we needed to have a definition of what we meant by skills. And this is where the Esko Framework came in. We borrowed from them in terms of how we wanted to identify sentences as skills or not. And then secondly, we also needed to build out a training set. So a number of labelers within the data analytics practice were presented with job adverts, and they highlighted phrases or tokens within sentences that were skills. And then finally, when we evaluated our machine learning model on a held out test set, the model was able to correctly identify sentences as containing a skill on 93% of occasions. So just to provide a little additional context, here we see a job advert, and you can see in the baby pink, these are kind of skill phrases that a labeler would have identified. And what we found was around 25% of sentences within job adverts were classified as skill sentences. So now I'll just pass the proverbial mic over to Liz, who will talk about the next few steps.
Thanks, India. Yeah, so as India said, the next step is extracting skills. And we started with the skills that were, the skill sentence that were extracted using India's algorithm. So we had this list of skill sentences from 5 million job adverts, which were then cleaned up a little bit. So stop words were removed. The next step was using the state-of-the-art BERT sentence transformer model to embed those sentences into a numerical form. We then used UMAP algorithm to reduce those embeddings to 2 dimensions. And then we applied the DB-scan clustering algorithm to find skills. And how this worked was we'd cluster the sentences to such a granularity that each cluster represented a single skill. And then we could also name the skill. So that's how we extracted the skills from skill sentences. And here are some of them in that 2D space. So each point represents a single skill, and just overplotted as a selection of the skill names that we chose. So down at the bottom, you've got things like languages. This bleeds into skills to do with personal attributes. Then we've got over in the right, customer services and marketing type skills, financial skills. And then over on the left, we've got skills to do with food and cleaning and care skills. And then the final step in the methodology was building the taxonomy. So based off those skills in their 2D coordinates, we applied k-means clustering to get out those 250 level C skill groups. And then we applied that method again to get the 90 level B skill groups. And then on the third step, we took a manual approach. So we, 3 of us sat down and kind of looked at those level B skill groups and decided how they should be grouped together to find those 11 level A skill groups on the highest level. So some examples of those skills in the taxonomy. So you might have the level A skill group to do with attitudes, communication and social skills, and those are broken up into things like time management or compassion, and then they can be further broken up into meeting deadlines and workload management. So on the analysis side of things, we did a few things. So firstly, we did a bit of an evaluation. We also looked at skills for certain jobs. We identified some transversal skills and also looked at which regions specialize in which skills. And finally, how did the skill demands change after the onset of COVID-19? So in terms of the evaluation, we were really asking, does the taxonomy make sense? And how we did that was look at the job titles in the data that we had and asked, of the skills that are mentioned in those job adverts, do they fit into the categories that we'd expect? So we see for history teachers, most of the skills mentioned there are in the childcare and education cluster. And for part-time cleaners, most of them are in the food, cleaning and safety cluster. So we felt like the comparison was quite consistent with what we'd assume. And something we can do with the job title data is also have a look at job skills for certain job titles. So here they are for cleaner job adverts. So as I mentioned, the highest proportion are in the food, cleaning and safety cluster. And I'm just giving some real sentences from those job adverts there. But there's also things to do with attitudes, communication and social skills, like using your own initiative. In the administration area, like supervising and going to meetings. In physical skills might be like driving a car, and customer service skills, as well as some other miscellaneous skills like following regulations. We can also do a comparison of jobs. So perhaps for similar kind of jobs like data scientist and data analyst, you can have a look at how those skill proportions differ. So here we have the level B skill groups for those jobs, and you can see there's an overlap and vaguely similar proportions, but there are some differences. And in particular for the data scientist, the fifth most common skill group was to do with systems design, whereas for data analyst, it was more to do with Excel. Another piece of analysis that we did was look at transversal skills. And these are skills needed for a broad range of occupations. So they're not just specific to a particular job. And we identified these using a co-occurrence network approach. And the skills that we found were most transversal were relating to communication and interpersonal skills. So another piece of analysis was to do with which regions specialize in which skills. So we could look at the proportions of skills from the different level A groups by region, and we can find things like in London, the digital and technology proportions are a lot higher than they are in, for example, Wales, where they're the lowest. And similarly for the manufacturing, engineering and physical skills, these are the lowest proportions in London, but the highest in the West Midlands. And some other notable outliers for the cognitive skills and languages group, these are particularly high in Wales and London, and that's because of the languages side of things. Northern Ireland has a high proportion of food, cleaning and safety skills, and the North East has a higher proportion of childcare and education. Our taxonomy also reflected the strong logistics sector in the Midlands. So this region contains most of the Golden Triangle for logistics because of its central location in the UK. And our taxonomy showed that the East Midlands had the highest proportion of skills to do with driving, engineering and stock management as compared to the rest of the UK. The final piece of analysis that we performed was looking at how the skill demands changed after the onset of COVID-19. And as you may expect, there was quite a high increase in skills to do with healthcare and a decrease in skills to do with the service industries. So in conclusion, we feel like the key strength of our method is it doesn't make presumptions about the underlying list of skills or the grouping of these skills. And this allows us to detect new skills as soon as they emerge within job adverts. And we hope our taxonomy could do a few things. So firstly, be used to inform revisions to existing taxonomies, such as the European Commission's Esko Framework, by identifying new skills and new skill groups. Secondly, it could act as a base, or at least a starting point, for a UK-specific skills taxonomy, where experts could add branches to the taxonomy that capture skills that are not typically mentioned in job adverts or online job adverts. Thirdly, as I've shown, it could be used to provide rapid analysis of shocks like COVID-19. And it could also be used to enrich careers advice and training in certain occupations by providing very detailed descriptions of the skills required in each role. So just some next steps from us. So be good to compare the skills extracted in this taxonomy with those expert-derived list from the ESCO skills, and examine the differences in skill demands over time, which would allow us to see emerging and declining skills. And finally, we plan to use the skill sentence classifier component to the project in another of Nesta's project, which is the Open Jobs Observatory. So thanks for listening.
Okay, thank you very much for another very interesting piece of work. We've got a question in the Q&A. Okay, Georgie, again, cannot read the question, so would either India or Liz like to read and answer this question?
Okay, so how much variation did you find in which skills appear for the same occupations? I don't think we performed this analysis. So you mean like within different job adverts for the same occupation, how much do the skills? Yeah, well, we haven't looked into that, but yeah, I'm sure that'd be really interesting to have a look at.
Okay, and there is a question by Lei Xu. Lei, would you like to unmute yourself and ask the question?
Oh, yes, thank you. Hi, Slade. May I ask, does your methodology differ, job tasks and skills?
So you mean in terms of, in the job advert where it might mention what you intend to do for the job as well? We try to filter out most of that using the skill sentence classifier. So that should hopefully get out sentences which are saying, in this role, you will be expected to do such and such. So we do try to filter out most of those role-specific sentences. They do creep in a little bit though, because it's not a perfect classifier.
Yeah, I think your methodology is very good, innovative. It's just to me like you firstly extract the sentences. Is more like a job task to me, right? For instance, for house builders, they build house. That's the job task, but they can use different skills if they manage the materials. Using by making foam, by making cows, that's a skill. That's what they do. But if they manage the materials using computers, I think that's a different skill maybe. My question is whether your methodology, you think the methodology has the potential to distinguish those.
Yeah, I'm not sure whether it distinguishes them, but rather would remove the kind of job specific ones. So yeah, I'm not quite sure if I've answered that properly, but
no problem. Thank you.
I don't know if you want to jump in on that, India, or anything.
I think that sounds about right. Maybe just to kind of give a bit more context about the ESCO framework. So they distinguish skills across 4 different categories that would fall within knowledge, skills, attitudes, and values, and then language, skills, and knowledge. So that's kind of what the labelers were presented with. And that's how they identified sentences that would be skills.
Okay.
Thank you.
There is another question from Martin Christian Kent. Would you like to ask your question, Martin?
Yeah, thanks. It's really interesting. I just really want to know why you chose ESCO rather than ONET, which tradition has been used.
I suppose to clarify that when we use ESCO, it would be to give our labelers of skill sentences a kind of broad idea about what a skill is. So correct me if I'm wrong, India, but it was more of just finding something to give them a definition of what a skill sentence would include. So I'm not aware that it would make a big difference, unless I'm very mistaken.
No, we used ESCO kind of as a code book more than anything for our labelers.
Okay, and then we have another question from Angus Stephen. Would you like to ask your question, Angus?
Hi, yeah, can you hear me?
Yes.
Yeah.
Great. Yeah, no, it was. So I work in the Treasury on the sort of labour market analysis team, or at least one of them anyway. And my question is how feasible it would be to run this type of, I guess, analysis on a quarterly basis to track dynamic changes in the sort of skills demanded in the labour market, or whether it's kind of like I'm not quite sure how long it takes to run the classifiers and clean the data properly, but it would be good to get a sense of that anyway.
I think it would be very possible. It's nothing takes too long. So having new job adverts come into the pipeline quarterly, I think would be very doable to process, and extract skills from. The only, I guess, what you'd kind of want to do is to retrain the algorithm periodically to reflect new skills that come into it, which might, you could imagine in that kind of plot of the skills in 2D space, if there's an entirely new skill set, which we can't even think of now, they might come out as outliers and it wouldn't quite fit into the current set of skills. So, but yeah, I think, and that's something we've talked about before, trying to get it kind of in some pipeline of getting new data in and seeing how they change.
Yeah, that would definitely be really interesting. Do you, from the analysis you did do, did you get a sense of how often new skills crop up?
No, not really, because the only temporal differences we did with the COVID-19, and that was pre and post March 2020. So it wasn't really, we didn't really have a look over time, no.
Okay, yeah, that makes sense. But thank you.
Okay, and then we have a question from Sanjeev.
Hi, Michela. Can I just check? Can you hear me?
Yes, perfectly clear.
Excellent. Thanks for that presentation, Liz. For the rest of the audience, I have to declare a vested interest. I've been involved in the work. I think it's excellent stuff. I have to say that. And I genuinely believe that there's a lot of good work being done in this space by many people. And pre or post-COVID, there's a lot of policy interest, how this area will change, what's going to happen to our education system, where the new jobs going to come from, global value chains are broken, etc. But I just got two leading questions for you, Liz. One is, can you just briefly describe the scale of the data sets and the observations you've got that underpin this? Because I think that richness probably didn't come through as much. And the second one, probably to whet Angus's appetite as well, is what potential analysis do you think you can generate from this? Because I think there's quite a lot of potential here for sure. Thanks.
Yeah, thank you. So yeah, in terms of the scale, we've got, it's the taxonomy is created from 5 million job adverts, and that translates after you apply the skill sentence classifier and various cleaning of particularly short sentences. That's 3.6 million sentences. So yeah, there's a lot that goes into it. And on the other point of analysis questions, I suppose the really cool one to have a look about would be the leveling up agenda. So it'd be great to see a real deep dive into those regional differences in skills, plus the temporal side. Obviously, what's being presented is like the just COVID and just regional differences. So it'd be really nice to see those combined.
Thanks.
Okay, another minute. We've got also a question from Adrian in the chat. Sorry, Adrian, I neglected that because I was checking the Q&A, but would you like to ask this question?
Yeah, I just said how stable are the clusters over time. It sort of relates to this kind of temporal issue. I know previously when I've kind of done automatic clustering, when you do it over time, you get a bit of a challenge because basically the clusters can merge in different ways, and then your comparability to previous periods, it can be quite tricky. So I just wondered what you'd kind of thought about that area.
Yeah, I suppose in terms of your question about the probability threshold and the clustering.
Sorry. Yeah, the probability threshold. That was my previous one.
I was just reading
to Elodie. So this one was just how stable are the clusters over time.
I see. Oh, yeah, that makes sense. We haven't really done any analysis of the clustering over time. It's kind of just using all the data to extract skills and form the taxonomy. So yeah, we haven't looked at that yeah, we did some analysis on like vocabulary size over time. So I think you could probably do something to do with seeing how adding more sentences from more recent job adverts might change that makeup of data in there, and yeah, and see how different that is, and then consider reapplying clustering.
Great, thanks.
Okay, so if there are no other questions, I'll ask a question myself before moving to the next speaker. This is great work and provides a lot of information on the demand for skills, but have you thought of how to match this information with the supply of skills? Have you thought of a way of merging the two types of skills that are relevant on the market and maybe construct a new measure of skill mismatch or something along this line?
Yeah, that would be super cool. Yeah, I suppose that we kind of think about it being used by kind of careers advisors, but yeah, maybe they could also feed into what's available and stuff. Is there a data set that you had in mind that would have the...
Well, the data set that I've been using is LFS and APS, Annual Population Survey.
Okay.
It'll be interesting to see if there is a way of matching information from the two. But probably, it might be an issue for next discussion, next work. Okay, there is a request for slides to be shared. I think all the slides are going to be shared on the ESCoE website. And apart from this, I think there are no more questions. So thank you very much to India and Liz. Again, super interesting.